Good morning, my dear students. Today I will discuss about low power modes of MSP430. So in MSP430, there are about six power modes are available. Among that, five are low power modes. One is the actual mode, calling it as active mode. And by using of these low power modes, the power consumption of the MSP430 is very drastically reduced. So, and one more thing, even it is having very low power consumption, and it will be generally in the low power modes. From low power modes to the active mode, it can be transformed. It can be changed states from low power mode to the active mode within 1 microseconds of time. So it is for reducing the power consumption. And because of multiple low power modes here, there is a notable difference in power consumption. Not only this, the MSP430 in comparison with the other microcontrollers like PAC, STM, so there is a very power saving in MSP430, around 70% of power with respect to peak. And with respect to STM, there are about 41% of power is saved in MSP430. And because of low power modes here, a battery can be operated for a long time. Hence, the microcontroller can also be extended its life. And coming to the low power mode architecture diagram here, so to enter into the active mode or enter into the low power mode, so first of all, it should cross three reset buttons called as POR, POR, and PUC. Burn on reset, power on reset, power up cleared. These are the various reset functionalities at various difficulty situations in MSP430. Once it crosses all these, the MSP430 will be in a active mode. In active mode, it uses all of the peripherals that are available in its controller. Hence, it is going to consume more amount of power or more amount of current. And based on our importance or based on our need, it may change it to any of these low power modes from low power mode 0, low power mode 1 to low power mode 4. And if you observe the current consumption in each mode, in active mode, it is only about 300 microamperes or less than that. And this, so all devices, clocks, and modules are going to be in the active condition. Active condition. Nothing is turned off here. And coming to low power mode 0, this is the first low power mode in which CPU and its clock, calling it as master clock, are going to be disabled. The remaining are going to be active. And because of CPU and M clock are disabled, the power reduced to current consumption reduced to 85 microamps from 300 microamps. And coming to low power mode 1, here also CPU and M clock are disabled, and sometimes DCU also not used for SM clock. So because of this, in low power mode 1 also the power consumption is going to be reduced. And coming to the low power mode 2, in low power mode 2, along with the CPU and master clock, SM clock and the DCU are also going to be disabled. Hence, further, the current consumption is going to be reduced. Still, A clock and DC generator are going to be active. Coming to the low power mode 3, here also CPU, M clock, SM clock, and DCU are disabled. Along with that, DC generator is also disabled, but only A clock will be in the active portion. Because of that, current consumption reduced to 1 microamps. Coming to the last power mode, in which all are going to be disabled, even with the A clock also. A clock is also going to be the disabled. Because of this, the current consumption even reduced to 0.1 microamps. This is also called as RAM retention mode. Means here RAM retention is only available. The remaining all are going to be in the active condition. Sorry, in the active condition. And To shift from one mode to the another mode, the interrupts are needed. Because of interrupts only, they may be moved from one mode to the another mode. If you observe the low power modes again, and for each and every low power mode, so the four stator flags are going to be having different values. For low power mode 0, only CPU off equal to 1 means only CPU off. CPU is going to be off, the remaining are going to be on. Whereas coming to the low power mode 1, CPU of E1 and SCG1 is also SCG0 also 1. Similarly, for LM2, CP of is 1, SCG1 is 1. And for LM3, CP of 1, SC0 is 1, SCG1 is also 1. And for low power mode 4, all are going to be 1. When all are going to be 1, nothing but all oscillators or all clocks are said to be disabled. So because of that, the signal current consumption is very much low here. Whereas in active mode, all are going to be 0, hence all are inactive, hence power consumption was very more there. And other than that, so there are two intermediate low power modes that are applicable for the latest versions of MSP430, calling it as LPM 3.5 and LPM 4.5. That you can observe in this diagram. For active mode, all CPU, SM clock, A clock, and RAM retention all are in active position, whereas in low power mode, only CPU is going to be off. Only CPU is going to be off. Whereas in low power mode 1 also, CPU is off. Low power mode 2 and low power mode 3, CPU along with the SM clock. CPU itself contains M clock also. So low power mode 2, CPU along with the SM clock, both are going to be the disabled. Whereas in low power mode 4, CPU, SM clock, even A clock is also disabled except RAM retention. RAM retention will be there. But coming to the 3.5 and 4.5, in 3.5 and 4.5, even the RAM retention is also in the disabled condition. Means even that power consumption is also reduced in 3.5 and 4.5 mode. And here is the diagram for comparing various modes of MSP430, starting from active mode to the low power mode 4 for two different voltages, 3 volts and 2.2 volts. So for active mode, for 3 volts of VCC, if you consider, it starts from 300 down to 55, down to 17, then 0.9 and 0.1 microamps. Similarly, for VCC 2.2 volts case, for active mode 200 followed by 32, 11, 0.7 and 0.1. So in this way, you can observe that the current consumption is very drastically reduced when moves from active mode to the low power mode 4. And to enter into the particular low power mode, so these are the mnemonics that can be used in embedded C language of using CCS, like underscore BIS, that is a bit set, SR register GIE plus low power mode 0 bits. So these GIE should be there. So because interrupt is to be enabled for that enter into that mode along with its respective low power mode 0 bits, like a CPU of equal to 1. Whenever I say low power mode 0 bits, internally, it is defined as CPU of equal to 1. Similar for low power mode, CPU of 1 and the next one is also SM clock is also going to 1. That is oscillator is also going to 1. In this way, the respective low power modes internally it will contain respective flags. These are going to be set by using BIS SR register within parentheses GIE plus low power mode underscore bits. So in this way, we enter into the low power modes. And if you observe this diagram, so by default, the MSP430 will be in the low power mode. So while executing the low power mode, whenever some interrupt occurs, then only it enters into the active mode. till then it will be in the low power mode only. Till then it will be in the low power mode only to reduce the power consumption. If you observe this diagram, unless until interrupt occurs, it will be in the low power mode. When some interrupt occurs, because of that interrupt, so it is going to do the CPU activity that you can observe in the second part of this code. Maybe some GPIO toggle output, some function is here. After completing this function, again it went back to the low power mode, which will be in the main function, which will be in the main function. And suppose if you don't want to come back to the low power mode after executing some functionality, then you can do one thing. In ISR, you can use this command calling it as low power mode of an exit. So in this way, low power mode can be off even after executing the interrupt that will be in a active mode. So after executing this ISR and upon observing this code, it will go back to the main, but the low power mode will be disabled by this command and enters into the some function that is declared in the main function. Of course, after executing that, again it will enter into the low power mode. So in this way, so generally the MSP430 will be in the low power mode, and by interrupt we can get it to the CPU mode or active mode. So this is about the low power modes that are available in this MSP430. Thank you.